Let's wait few more minutes if someone is joining. I think I should start. No one is joining. A very good evening, everyone. My name is Deepak Kumar Patel. I am a PMR fellow at IIT Madras, and I am jointly working with Professor T. Pradeep and Professor Sundar Gopalagaon. This is my email ID, which you can mail on this email for any question, any clarification on this. So, since you have selected this course, structure, stereochemistry, and reactivity of organic compound, and an intermediate a problem-solving approach. This course was taught by Professor Amit Basak from IIT Kharagpur. As we discussed in the last class, today in this session we will going to have a discussion about the assignment 1. Assignment 1. This assignment 1 have 14 question. Each question have 1 marks. So let's start with question number 1. Question 1 is like consider the following molecules. See the molecules and identify the correct statement. So to solving this type of question, what you have to do, you have to see the option first. Like option itself suggesting like some molecule says sigma and S1, and sigma plane is all S1 is also a plane. S1 means 360-degree rotation and perpendicular plane, but this plane are different. So like this plane is, if a molecule is passing through this, the plane will be this. This option B is the molecule have the sigma and S2. S2 means if rotation with the C2 and one perpendicular mirror. The C option is molecule have C2 and S4. So 1 minute, we will go just by. We will. So these molecules have C2 and S4. C2 means rotation with 180 degrees. So this AR if you are rotating, if suppose a axis is passing through and you are rotating C2, what happened, like this AR will replace with this AR, and this way hydrogen will turn go to the here. Okay, na? So yeah, this option is matching, like this S2, this molecule have C2, and if there is C2, you just rotate this molecule with one C4 and corresponding perpendicular sigma, you will get the S4. So correct option is C. So here you can say, as I explain you, this molecules have the C2, this passing through this axis, this AR are replacing each other, 1 and 3, 1 and 3, and these 2 and 4 are going to exchange. For the S4, similarly for C2, or sorry, C4, then perpendicular plane, you will get this. So correct option is C. Coming to the question number 2, a flexible molecule is achiral if. So like from the option you will see, like one of the conformer has improper element of symmetry, and second option is none of the conformers have any improper element of symmetry. First of all, you have to understand what is the proper element of symmetry and what is the improper element of symmetry. So Cn, or the proper element of symmetry, any plane, either your plane or I or Sn, these are the improper element of symmetry. So when you are getting this type of things, it will be achiral. So option A will be answer. We can see here, like for an achiral compound, it is not necessary that all the conformations have to be achiral. The presence of even one achiral, here one achiral, due to the presence of improper element of symmetry, which I tell you guys, make the whole compound optically inactive. As for accounting for the chiral conformation existing for a major compound, one may figure out that for each such chiral conformation, there is always a mirror image chiral conformation present, which externally compensate for the optical activity of the former. It should be noted that such conformation equilibrium is only possible provided that the energy required for the conformation change is available under the experimental temperature. So means if any compound have the many conformation, if one of the conformation have this improper element of symmetry, that molecules will be achiral. So coming to the question number 3, consider the following. I hope I am audible and visible. My slides are visible. Consider the following two molecules P and Q. This is a P and Q. Identify the correct statement. So you have to look the option what is they are asking. Molecules P have S4 and molecule Q have I. So means you have to find out the point group, which point group these molecules belong, and whether this is symmetric or asymmetric. So for this, like what you have to look, you have to just find out the what type of symmetry element is present in this. So have you seen any I in this, any from any distance, like if suppose you have any point here, you are getting equidistant element present. If this is pH, you are going in opposite direction, you will get pH. If you are going opposite direction, you will get hydrogen. If you are going opposite, you will get this phenol. So there should be an I in these molecules, I present. And what about this? So these molecules, you have to look very carefully whether you first check whether these molecules is, have the center of symmetry or not. If you are making a point here, you are drawing here, you are getting here, you are getting, but these molecules are in opposite direction. This or this are in the same direction. Sorry, same direction, not in opposite direction. So this don't have the I. It don't have the I. So is there any other symmetry operation is there? You just pass through one plane here and rotate it. you will get or not any if you are rotating suppose C2, you will get, you have to get like as I explain you, like so here the option B was correct. The molecule P have I, which I explain you, and this Q molecules have C2. When you will replace rotate with the 180 degree, this will go there and it will be C2. So here they have explained like how it is, like they first determine the RS configuration. If it is R, definitely equidistant it will be S. So this system is S, this is R. That's why it is a chiral in nature also. This will rotate in one direction optical light, and this will rotate in another direction of that optical light. What about this compound? This is R, this is also R. So there this is clear, like this it don't have I. What about C2? There is plane of axis of symmetry. If this passing through this axis, this will turn out to this. So the option B is correct. Coming to the question number 4, the two compound X and Y below are. So to solve this type of question, I'll give you simple trick. Like you just find out the RS configuration. You will easily get the whether this is enantiomer or homomers or diastereomers. So like if you are finding the RS configuration, this is 1, this is 2, this is 3. So 1, 2, 3. But fourth group is up. So this will be rotated in another direction. So it is S. You come to here, look like this is 1, this is 2, this is 3. Fourth is going away from you. So if it is, it should be rotated like this. But sorry, I did wrong. It's wrong. Okay, come on. 1. No, this should be 2, and this should be 3. So 1, 2, 3, and it is opposite. So it will be like this. So it will be R, not S. So here, like this will be 1, this will be 2. According to priority, this will be 3. Because priority we have to give this now. This joining to the 3 carbon. This is 4. So this is 1, 2, 3. So it is also R. So R means they are homomer. This center is also similar. What is the configuration of this? It will be this also. Or you can do also one thing. Let me erase. You can find out with for this center also whether this is R or S. If it is like priority number 1 will be this near 1, 2, and 3. So you are going to like this 1, 2, 3. 1, 2, 3, and fourth one is below the plane. So it will be like this only. So it is S. For this case, 1, 2, 3, and it is 4. Here the fourth group is above the plane. So whatever it will be changed. 1, 2, 3. It's coming R, but it will be like S. It should be R, but it will be S. So there is no change. This center was like R, and so no change in the. So overall this molecule is homomer. You can also find out by the simple rotation. Like I'll tell you. Simply just rotate this. you will get. This is the easy trick to find out the whether this if there is a one any change, if this 1 minute. So if this center, suppose it is R, it is S, and it become S, it become R. So it will be enantiomer. If this center remain S and this center become R, so these two conformations become diastereomer. If so, no change. Homomer. One change, all change. Enantiomer. One change only, it will be diastereomer. You understand, like this, if this was R, this was S, if both change, this become the S, this become the R, so it will be enantiomer. If none of no change, like in this case, this will be homomer. Like in this case, it's a homomer. But if one change, another stereo center remain unchanged, it will be diastereomer. It's a simple trick. And they have given some another way explanation, like you just draw the chair conformation of this methyl group on a axial position, this hydrogen on axial position for the first X one, and for Y this will be the axial, this will be X. So just flip this on this will be the superimposable. That's why it's like how the flipping you will be having, they have explained, like this methyl group is below, you just take the flipping here, you will get exactly matching. This is methyl, this is hydrogen, so this is a homomer. The same way, but visualizing like that is very difficult. So just find out the whether this is R or S, whether all change or no change or one change. If all change, enantiomer. If no change, homomer. If one change, diastereomer. Very simple. Coming to question number 5, which of the following compound the value of symmetry number sigma is the same as the order? So any molecules having the symmetry number same and order H equal when the molecules is chiral. So like this is a trick. When you are seeing any option, you have to find like whether which molecules is chiral, transdecalene, whether or this or this. So which is chiral? So from the, like if you have gone through the lecture, you will understand this molecules is looks like chiral. So just from option A is the answer. So the detailed solution only for a chiral molecule, which I was saying, asymmetry element is always equal to order H. So the twist-board conformation of cyclohexane, this molecule is chiral, having the D2 symmetry. D2 symmetry means whenever for C multiply by 1, for D multiply by 2, for T multiply by 12, as sir taught in class. So 2 multiply which is dn na? dn means 2 multiply 2, 2 multiply 2. So this is 4 symmetry number, order also. For the transdecalene is achiral. Why? Because there is passing of plane of symmetry. So this have the one C2, one C2 passing through this, and one sigma H, perpendicular sigma H. Sorry, this plane. So this belong to the C multiply means 1 multiply 2. Here I will 1 multiply 2 multiply 2 for H. So it will be 4. So for this case there is only S. For this case D5D. So for the twist board conformation of cyclohexane have the symmetry number equal to order. So correct option is A. Coming to the question number 6, consider the following molecules. This molecule is adamantane. So here you have to see like this. These are the different functional group: AR, AR, AS, AL. So you have to look the option how you can solve this type of question. The option is the molecules belong to T point group. T means tetrahedral, and the order H is equal to 12. If the B option is the molecule belong to C4 point group, and the symmetry group sigma is equal to 4. C4 means 1 multiply 4. The molecules belong to D2 point group, and the order is equal to 4. So for the to solve this question, you have to find out the from which point group these molecules belong. Can you if you are passing any axis from this, you will get any replacement of this? No, because this is different, this is different. So this axis is not a principal axis of this. Suppose if you are passing through this, yeah, this can be replaced with this, and this can be replaced with this. So the principal axis is this. This will be the principal axis, not this. So the solution of this question is, we just pass through this axis. This is the principal axis C2, and these molecules also have the S4 axis along this. So the given advantane derivative belong to the S4 point group. It has the S4 and a C2 axis. This C2 axis I told you passing through. So the number of different but indistinguishable arrangement arise out of the rigid rotation is 2 only. The Y2 because S4 which is having the C2 like only E element of symmetry, and one C1 one C2 symmetry. Coming to the question number 7. So this question is like, which of the following compound from A, B, C, D have the same value of order? This question professor taught in class. So you have to identify this. I will give you some time to solve this question. I will wait for 1 or 2 minutes and let you to solve. Then I will explain. I hope you tried. Let me explain you. We just find out all these molecules belong which point group, and from there you can find the order. Suppose this, if you are targeting this molecule, just draw the principal axis and find this is like there is a C4. These are rotating, and there are plane. So C4 is there, and plane is there. Like this you can find on this. As I told you, the professor have explained this type of question. in this lecture. How they have he has explained, like if there is a as I show you know, C is equal to 1, D is equal to 2, tetrahedral is equal to 12. How you can multiply? Suppose there is a D2, D2, D. So 2 for D, 3 from this, 2 for this. So 12 order. For tetrahedral, there is multiplication of. So any DN point group have the Cn plus NC2. And any tetrahedral have the 4C3 plus 3C2 type operation. So coming to the answer of this question, how we can solve this? So the correct option was C. The molecules A and C both have the value of order H equal to 8. So you have to find out these molecules belong to which point group. You are passing one axis, principal axis, rotating it as C4. Sorry. And you have to find out what is there any plane? Yes, there is plane. If you are passing one plane here, one plane here, one plane here, another plane here. So all the cutting parallel to the principal axis. So the point group will be the C4V. And for C4V, how you can multiply? 1 multiply 4 multiply 2. You will get 8. For this molecule first of all is planar. So it's very easy job for you. What we have to do? You have to check like this group are opposite. So D2, simply you can say, pass through one C2 axis. We just check whether any perpendicular C2 is there or not. Yes, it's there. If you are passing through this C2, this C2 are perpendicular. So D2 means 2 multiply 2, 4. As sir explained in class, this question I have explained in class. For this, you have to do very simply. You have to just find out the point group. So it's belong to D2, D point group. For D2 D point group, 2 multiply 2 multiply 2 will get 8. For this Allen's type system, again you have to find out the C2. This C2 is a little diagonal C2. So like one diagonal C2 like this. And there is no any mirror plane. So this is the C2. So these molecules and the first molecules are having the same order of the symmetry operation. The correct option is C. Consider, so the next question is, consider the following 3 molecules A, B, C. You can see the A is adamantine, B is this, and C is this. Identify the correct statement. Sorry. All belongs to ABC. All molecules ABC belongs to C1 point group. C1 point group means all the elements of the C1 point group. First of all, this you have to know. And A and C belong to C2. Is it? You can see, is there any C2? Yes, I can see one C2. Can you see? I can see here one C2. If I will rotate, it will go. This is also looking like C2. If somehow, if there is a, this is opposite direction, like this. If I am passing one axis through this, one C2 is there. So yes, A and B belongs to C2 point group. What do we say? Let me check whether this A belongs to C2 or not. Yes, yes, it belong, because when I will rotate this molecule which is down, it will go up. Which this hydrogen is up, it will go down. So this is C2, and this already I explained. This will replace with this, so it's C2. What about this? So for this you can do one thing. You can draw just simply chair conformation. This chair conformation is not good, but anyway we'll manage. So these are opposite direction. Suppose if one is I'm drawing this na, this is above the plane and this is below the plane. Is there any way to find out any symmetry? No. So this belong to C1. It can't have any proper axis of symmetry, no principal axis we can rotate, no plane. By default we will see like, oh, there is a plane we can cut. No, but you are cutting for this will not, this don't have any reflection, so there is no plane. So the correct option should be from like D. Yeah, the A molecule AB belongs to C2 and this belongs to C1 actually. I told you, no, there is no plane, no symmetry. Coming to the question number 9, consider the following point group: DND point group, SN point group, CNH point group, and DNH point group. A molecules belonging to which of these point groups will never possess an S3 axis? So you have to focus here question S3. The options are only S point group, both this, only CN. So for like you have to first analyze the question. They have given this option from this only. You have to which can not possess, never possess S3. And you know for any SN, N should be even. So this first option you should go. Only SN point group can never possess. Problem solved. All other can have, but this can never have SN. This should be always even. So for SN point group, N has to be always even, which I was saying. So a molecule belonging to SN point group will never possess S3 axis. When the value of N is odd, in case of SN, the molecule must coexist with CN and sigma H. Coming to the question number 10. This question is little bit interesting and tricky. I will give 2 minutes to you to solve. Okay, I hope you have tried. So the question is, identify the correct point group of the following chromium based sandwich complex in a given staggered conformation. So this question is saying this is a staggered conformation first of all. So this is the structure. The option is S6 point group, C3V point group, D6V point group, and D3D point group. For this, to solve this question, you can simply merge this together. We just press it and bring it to and make a sandwich. So how it will look like? Pardon me, my drawing is not that good. So like if I am taking this as a up, methyl, methyl, so methyl, there, not this, wait, wait it. And what about this? This down one. Down one methyl will be like this. Now it's easy to solve this, na? I hope you understand. Chromium is in center. So simply you just pass one axis. Suppose if you are passing, this all should be replaced. This down one is down, and this up one, up will replace with up, and down will replace with down. So if you are passing through one C3, C3, this will replace to this will replace to this, and this will replace to this. But what about the down one? Is down one replacing? Yes, it is replacing. This will replace the dotted one replace with dotted one. So these molecules have C3. We are sure about this. So this have C3. I am just erasing for clarity. What about, is there any plane? I just see. If we are cutting with this plane, there is no plane like that. So this will not replace. What about this plane? If we will cut using passing through this. So this solid one will reflect with this solid one, and this dotted one will reflect with this. Yeah, so there is a plane, sigma plane, and this plane is intersecting, bisecting, or like cutting through the principal axis. Means it's not a perpendicular, so it is a sigma v point, sigma v. Like that we will get another this type of three sigma. It's very clear from here. Sorry, that is not sigma, it's a d because it's diagonally going through. I should correct that. It's sigma d. Because it have this perpendicular C2. So whenever there is a C3, this type plus 3C2 is there perpendicular. So what is happening? So this belongs to the D3D plus sigma d is there which we can clearly see in this figure. So top view, you are pressing what this was, for my case it was dotted, and here they are solid. So if you are visualizing like this, just passing through this, so you will get C3 plus the plane, this plane sigma d, and the perpendicular C2. So the C3 axis perpendicular to the plane of the representation, and the passing through the center of molecule, also S6 molecule collinear with C3. We just go through with this to understand what they clearly I was mentioning. The given molecules have C3 and S6 axis passing through right through the center of the two aryl ring yes, is passing through this aryl ring, and also passing through chromium. The molecule has 3C2 because it have the C3 point group, and this one ring, it has also got 3 sigma D passing through the 2 methyl ring and the chromium oriented along the vertical axis containing the 2 opposite methyl group. As I was saying, like this will reflect for the, if you are going with this methyl will replace, and this is the mirror image of this. So this molecule have the C3D point group. It's very interesting question. Coming to the question number 11. So the consider the following compound A, B, C, D and F and arrange them in a decreasing order of the value of their symmetry number. So this question will test your knowledge of the symmetry operation. So I will give you 1 minute to just go through this and try. Okay, we'll try. I hope you tried also. So the consider this A, B, C, D, E, F molecule. So just find out the what type of symmetry is present in this. Based on that, you can easily find out the symmetry operation. Like here, that for A molecules, there is a C2V symmetry. How C2V? Just go through this. It will C2 passing through this. There is C2, and there is one plane also. This plane contains this principal axis. That's why C2. So symmetry number will be 2. One rotation, one plane. For this molecule, is there any rotation axis? No, you can't rotate. This way also you can't rotate. So what you have to do? You have to find out any axis is, plane is there? No, there is no plane also. So these molecules don't have any symmetry. So CS. So symmetry number is only 1, which is universal for all the molecules have this one symmetry, which is E. So come to the C molecule. Is there any symmetry you are seeing? If you are passing through principal, no. Perpendicular axis, no. So let's pass through the in plane. If you are passing in plane, yes, this will be replaced with this. So C2 is there. C2 is there. Can you find any plane? Yes, if you cut the one plane passing through this principal axis, there is plane, no, not a perpendicular. So there are two planes. Sorry, one C2 and one plane. So C2V. Two operations are there. In this, no, because this will not have, because of this ethyl group, this methyl can't have any symmetry exchange. That's why it belongs to the CS, having the symmetry number 1. What about this? There is a symmetry of possible, I think. Yes. How we can see? Just past one principal axis, one axis, rotate C2, find out. And there is also possibility of perpendicular C2. Perpendicular C2 is also there. Whenever there is perpendicular, it belongs to D. So you have to find out is there any plane. You have to find whether that plane is perpendicular to the principal axis or not. Yes, there is a plane, and that plane is perpendicular. So that's why one plane is here is the plane H with this molecule. So this belongs to D2D point group, and D2 means 4 symmetry number. Another for this, no, because this methyl making trouble to this, this ethyl making trouble to methyl. So there is no any symmetry like that perpendicular. But there is one possibility. How? If we are passing through one in plane symmetry C2, not perpendicular, not like this, but in plane. So this will be remain the same place. This will be remain the same place. So C2 is there, and there is one plane also which contain this principal axis. That's why it belongs to the C2V. So the symmetry number is 2. So the correct answer is C. These molecules and these have the same. So the correct answer is C. You understand, like why C? This C. E, then A, B, A, C, F are equal, then B, D. Coming to the question number 12. Consider the following two compounds A and B. Identify the most appropriate option at equilibrium. The most populated conformation for the A belongs to C2 and B belongs to C2H point group. So like the question I have mentioned itself, equilibrium thing. Whenever these type of things will come, you have to always think that these molecules can exist in several forms. So one form will be in equilibrium with other. So you have to find out that. So this type of things you have studied in Newman projection. So you have to find out the stable conformation of this. How you can do that? Just draw 1,2-difluoro like this in a Gauche formation. So this fluoro-fluoro interaction will be there. That's why it's a very high, not very means stable conformation compared to other NT1. But due to the bulkier size of the chlorine, this will be prefer to the NT. Fluorine is like to have fluorine-fluorine interaction, but chlorine is very bulkier and electron cloud will repel. So that's why they will prefer to NT. So 1,2-fluoro will have the Gauche conformation, and this 1,2-dichloro will have the NT. So the Gauche conformation have the C2 axis only. There is no plane. So only C2 point group. You can see there is no plane. How this axis is passing through? You just like suppose if you are viewing in a laptop. Imagine your right side keyboard and right side keyboard and left side your screen corner passing through, and this fluorine will replace like that. Open book structure like similar way peroxide have no same kind. Open book structure. But what about this chloro? This chloro have one C2. This C2 we can clearly see in anti conformation, and there is a plane also, and that plane is perpendicular, not having perpendicular to C2. So sigma H is there and C2 is there. So it will become ultimately C2H point group. So the answer is 1,2-dichloroethane exists majorly in Gauche conformation at the equilibrium due to the hyperconjugation. Not only hyperconjugation, there is also fluorine fluorine interaction which stabilize this conformation, whereas the 1,2-dichloro, this will some typing mistake is here. Chloroethane exists majorly in anti-conformation. Why anti-conformation? To add the dipole-dipole interaction, because chlorine electron cloud is more, where they will repel each other. So the 1,2-difluoroethane at equilibrium, the most populated conformation belongs to C2. C2, why C2? Because there is no plane. But for chloro, there is sigma plane also. It will be C2V, C2H. Coming to the question number 13, consider the following reaction. This question is a little tricky. You have to find. I will give 1 minute only. Just see and think. I hope you have tried. So this will be the non-planar. This will be the planar. This is aromatic. It has the planarity. So you have to use your organic concept and try to find out this thing. So this have the top shape like this. So this system chord have the top. It have the C2 elemental symmetry. When you are applying C2, this thing will be replaced with this. So it exchanging. So the C2 point group is there, and there is also plane. This plane having this axis. So this belong to D2D point group, having the symmetry number 4 and order 8. How 8? For D, I like sir I have told you, for C multiply 1 D. I am just revising T 12. So D2D means 2 multiply 2 multiply 4, 8. But what about the product one? Product is planar in nature. So it have the C8. You have to rotate with C8, and there are 8 C2 also perpendicular. So this is the C8 and perpendicular, if the axis is this, perpendicular of this or 8 C2 like this. So these are 8 C2 and this 8 C2 are having same plane sigma D. So the point group will be the sigma D, this D2H. It should be D. This plane is also there. D2, one plane is there perpendicular. So whenever there will be plane which have the D and H, you will prefer the D also. So the highest priority is D2, D8H. And symmetry number is 16. How many symmetry operation you did? And the order is 32. How 32? You can multiply 2 multiply 8 multiply 2. For order. Professor taught this in class very well. So coming to the last question, identify the correct point group corresponding to the following fused polynuclear hydrocarbons A, B, C, D. So this is the molecules. You have to just, these are looking very scary, but no, these are not scary. When you look very carefully, you will find out there is some symmetry operation is there. So in this you can see like there is one symmetry. Suppose if this molecule is in a plane, so perpendicular to that plane passing through this, there is a symmetry operation which is C2. So this AR will replace with AR. C2 is there. So you will find out option A, CS, no, C2, 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 C2. So you like this, you can also terminate the other option, na? So for B, where will come B? So here the molecules AR, AS, so these are different. These are different. Okay. So is there any uh, axis will rotate? Principal axis is there? No, you can't rotate. Neither. If it is S or RR, we can have one C2, but because of this can't be AR, AS can't be exchanged. So there is no rotation. But is there any plane? Yes, one plane is there in plane. So it will so this will not have any C2. So this option already cancel. Now cancel again. So this option also cancel. So now you have B and D. So this option matching with the. Now come to this, man. So here we will see, is this compound have any symmetry? Yes, it's very symmetry. It's looking very symmetry. Just here, one C2 you will pass, and also other C2 you can pass, and plane. What about this? You try. You understand? No? So as I explained, in this there is passing through like this. So this will replace with this, and these molecules have only plane, which I explain you. No, so it belongs to CS one group is C2, and this belongs to D2D. One plane which I said this, and there is a C2 perpendicular plane also. Sorry, C2. So this belongs to D2D, and these molecules have the I. Why? Because these are the symmetry, and these are sorry equidistant, opposite direction. If you will go from this point to here, you will get this air. R configuration, and this belong to S configuration. You are getting. Then this is I. If A again it's AR, no. Then you will have the different. Then it's not I, because as in first question I said like this confirmation should change in I. That's right. So the correct option is D. D means A belongs to C2 point group, B belongs to CS point group, C belongs to D2H point group, and D belongs to CI point group. So that's all for today. I hope you understand, and this problem solving session help you little bit. If you have any query, any doubt, please mail me. This is my mail ID. I will show you once. This is my email ID. You can mail me anytime. I'll try to respond. So I hope you understand little bit how to solve this question, and see you in next problem solving session. Thank you very much.